For centuries, the prevailing Western worldview has been built upon the materialistic mechanical model of Isaac Newton, a clockwork universe composed of separate particles of matter interacting according to precise physical laws and existing within objective dimensions of space and time. This model has long succeeded in describing many facets of our multifaceted reality, but increasingly, since the revelations of Einstein and the paradigm-crushing implications of quantum physics, Newton's world is quietly fading from view and being replaced by a more spiritual science. Lynn McTaggart wrote, "Up until the present, biology and physics have been handmaidens of views espoused by Isaac Newton, the father of modern physics. These, at their essence, created a worldview of separateness. Newton described a material world in which individual particles of matter followed certain laws of motion through space and time. The universe as a machine. The Newtonian world might have been law-abiding, but ultimately it was a lonely, desolate place. The world carried on, one vast gearbox, whether we were present or not. Our self-image grew even bleaker with the work of Charles Darwin. His theory of evolution is a life that is random, predatory, purposeless, and solitary. Be the best or don't survive. You are no more than an evolutionary accident. These paradigms, the world as a machine, man as survival machine, have led to a technological mastery of the universe, but little real knowledge of any central importance to us. On a spiritual and metaphysical level, they have led to the most desperate and brutal sense of isolation. They also have got us no closer to understanding the most fundamental mysteries of our own being: how we think, how life begins, why we get ill, how a single cell turns into a fully formed person, and even what happens to human consciousness when we die. Newton's mechanistic, mathematical model is attractive with its law-abiding, predictable structure, but it repeatedly falls short in describing a wide array of phenomena which classical physics is thus forced to deny or ignore. These include things such as consciousness, the observer effect, the measurement problem, Heisenberg's uncertainty principle, non-locality and quantum entanglement, particle-wave duality, bilocation, telepathy, psychokinesis, clairvoyance, precognition, out-of-body experiences, near-death experiences, ghosts, shamanic spiritual healing, acupuncture, prayer, the placebo effect, psychoneuroimmunology, and many more anomalies, all of which are at odds with classical physics and will be examined in the coming chapters. Fritjof Capra wrote, "The worldview which was changed by the discoveries of modern physics had been based on Newton's mechanical model of the universe. This model constituted the solid framework of classical physics. It was indeed a most formidable foundation, supporting, like a mighty rock, all of science and providing a firm basis for natural philosophy for almost 3 centuries. The stage of the Newtonian universe, on which all physical phenomena took place, was the 3-dimensional space of classical Euclidean geometry. It was an absolute space, always at rest and unchangeable. In Newton's own words, absolute space, in its own nature, without regard to anything external, remains always similar and immovable. All changes in the physical world were described in terms of a separate dimension called time, which again was absolute, having no connection with the material world and flowing smoothly from the past through the present to the future. Absolute, true, and mathematical time, said Newton, of itself and by its own nature, flows uniformly without regard to anything external." The first steps away from Newtonian physics came with Einstein's theory and subsequent experimental proofs of relativity showing Newton to be incorrect in his view of absolute space and absolute time. Instead, both space and time have proven to be relativistic, interrelated concepts, which are now more appropriately referred to as space-time. As written by physicist Mendel Sachs, the real revolution that came with Einstein's theory was the abandonment of the idea that the space-time coordinate system has objective significance as a separate physical entity. Instead of this idea, Relativity theory implies that the space and time coordinates are only the elements of a language that is used by an observer to describe his environment. Einstein showed that space and time are not absolute structures with independent a priori existence as classical physics espouses. In fact, space and time are relativistic and subjective, a notion which metaphysically places them subordinate to the mind or consciousness perceiving them. The mystical implications of this discovery are vast and will be covered in detail later, but first let's examine whether or not we even live in a material universe at all. What has modern physics discovered about atoms, the so-called building blocks of matter? Peter Russell wrote, "For 2,000 years it was believed that atoms were tiny solid balls, a model clearly drawn from everyday experience. Then, as physicists discovered that atoms were composed of more elementary subatomic particles, electrons, protons, neutrons, and such like, the model shifted to one of a central nucleus surrounded by orbiting electrons. Again, a model based on experience. An atom may be small, a mere billionth of an inch across, but these subatomic particles are 100,000 times smaller still. Imagine the nucleus of an atom magnified to the size of a grain of rice. The whole atom would then be the size of a football stadium, and the electrons would be other grains of rice flying round the stands. As the early 20th century British physicist Sir Arthur Eddington put it, matter is mostly ghostly empty space. 99.9999999% empty space, to be a little more precise. How can something which is 99.9999999% empty space be considered the building block of matter? And what is the fundamental stuff of the universe, if not matter? If there is almost no substance to our seemingly solid, tangible world, what causes the illusion? German physicist Hans-Peter Dürr keenly noted, "Matter is not made of matter." So what is it made of? David Icke wrote, "For a start, what we perceive to be physical and solid is anything but. Science says that what we see as form, people, buildings, landscape, etc., are made of atoms. Okay, but the trouble with the solid world theory is that atoms are not solid. More than that, they are basically empty. How can something that is not solid create a solid environment? It can't. Atoms consist of electrons orbiting a nucleus, protons and neutrons, but it is the proportions that tell the story. Atoms are more than 99% empty space to our human reality, yet they are described as the fundamental building blocks of matter, yes, solid matter." Aaron Adani wrote, "Examine each part of the cabin. The walls are made of wood. What makes wood what it is? A configuration of wood cells exist as a log, and each of these cells cannot exist without a configuration of molecules. Likewise, each molecule is composed of atoms. Each atom contains electrons, protons, and neutrons. Each atomic particle is composed of quarks, etc., etc., etc. Everything can be broken down into parts. Even if somehow a thing was found that could not be broken down, it would still have parts, because if it did not, it could not be used to make more complex things. Anything that has spatial extent requires that it has a front, a back, a shape, different parts. At the level of atoms, the distance from one atom to another in relationship to the diameter of the nucleus of the atom is astronomical. There is more emptiness in the atoms composing the wall of a cabin than there is matter, and this goes for all matter. All matter is mostly emptiness. What prevents your hand, for example, from passing through a wall is not that there is some thing or things, atoms, in the way, but more so because there is an atomic energy field that prevents the atoms from one's hand to pass by the atoms of the wall. When touching a wall with your hand, both the wall and your hand are composed of 99.9999999% empty space, so your sensation of touching something comes not from physically colliding hand atoms with wall atoms, but rather from an energetic charge between them. That energetic charge is then electrochemically interpreted by your brain into your felt experience of wall. David Icke wrote, "How can something that is not solid be the building blocks that construct this solid wall I am looking at now? It can't. Our brains do it. With the emergence of quantum physics, science has had to concede that atoms are not solid. The atoms that comprise physical matter are overwhelmingly empty, and even illustrations of this are misleading because there is not enough room in a book or science paper to accurately depict the proportions of particles to empty space. As one writer put it, if an atom was the size of a cathedral, the nucleus would be about the size of a 10-cent piece. The rest is empty to the perception of the five senses, because it consists of energy vibrating on wavelengths higher than the physical, and even the particles are found to be empty as you go deeper into the subatomic realm. If you magnify anything powerfully enough and go deeper than the atom, you will find that nothing has solidity. No, not even buildings, cars, mountains, or the bones in your body. It's illusion. If you find this hard to accept, think of your dreams. You dream in three-dimensional images, and yet no one claims they are solid, do they?" Fritjof Capra wrote, "Quantum theory thus reveals an essential interconnectedness of the universe. It shows that we cannot decompose the world into independently existing smallest units. As we penetrate into matter, we find that it is made of particles, but these are not the basic building blocks in the sense of Democritus and Newton. They are merely idealizations, which are useful from a practical point of view, but have no fundamental significance." Nobel Prize-winning physicist Niels Bohr was the inventor of the Bohr atom model, seen in every high school physics and chemistry textbook, depicting the atom as a mini solar system with a central nucleus orbited by bands of electrons. He created this model of the atom with which we are all so familiar, yet he himself knew the model was incorrect at a fundamental level. He wrote that, "Isolated material particles are abstractions, their properties being definable and observable only through their interaction with other systems." In other words, no atom or subatomic particle has an isolated, separate existence. No material particle has independent properties or location as distinct from any other. At the atomic and subatomic levels, no thing is separate from everything else. There is just one field of pulsating energy that composes the entire physical universe. It has been called the ether, the field, the quantum field, the zero-point field, and many other names, all referring to this essential energetic oneness. So, not only was Newton's classical physics incorrect about absolute space and time, it was incorrect about the universe being composed of separate particles of matter. Lynn McTaggart wrote, "This world of separate should have been laid waste once and for all by the discovery of quantum physics in the early part of the 20th century. As the pioneers of quantum physics peered into the very heart of matter, they were astounded by what they saw. The tiniest bits of matter aren't even matter as we know it. Not even a set something, but sometimes one thing, sometimes something quite different. And even stranger, they are often many possible things all at the same time. But most significantly, these subatomic particles have no meaning in isolation, but only in relationship with everything else. At its most elemental, matter cannot be chopped up into self-contained little units, but is completely indivisible. You can only understand the universe as a dynamic web of interconnection. Things once in contact remain always in contact through all space and all time. Indeed, time and space themselves appear to be arbitrary constructs, no longer applicable at this level of the world. Time and space as we know them do not, in fact, exist. All that appears, as far as the eye can see, is one long landscape of the here and now." Everyone knows Einstein's famous formula E equals mc squared, meaning energy equals mass times light speed squared. What we are seldom taught, however, are the implications of this equation. E equals mc squared shows that matter and energy are really just two different forms of the same thing. Einstein's formula and quantum physics have both verified that all matter is really just energy vibrating at a low frequency. This means that energy, the one undifferentiated field of quantum zero-point energy, is the primary reality. So-called empty space, solid matter, and separate forms are just subjective interpretations of the one underlying energy. As Albert Einstein himself said, we may therefore regard matter as being constituted by the regions of space in which the field is extremely intense. There is no place in this new kind of physics both for the field and matter, for the field is the only reality. Fritjof Capra wrote, "The discovery that mass is nothing but a form of energy has forced us to modify our concept of a particle in an essential way. In modern physics, mass is no longer associated with a material substance, and hence particles are not seen as consisting of any basic stuff, but as bundles of energy. Experiments in quantum physics have shown that atoms and all subatomic particles are more like verbs than nouns. They are more like energy bundles or patterns of quantum potential than they are like solid billiard balls or mini solar systems. The underlying primary reality is the energy field, and energy itself is more a verb, an action, a potential, than a noun. It's not some set thing. When we peer deeply into the subatomic levels of matter, we see only this energy, this constantly flowing, interacting field. To make sense of it, we create nouns and models like atoms, electrons, and quarks, but the most appropriate model would be a verb like universal energizing." Fritjof Capra wrote, "These dynamic patterns or energy bundles form the stable nuclear, atomic, and molecular structures which build up matter and give it its macroscopic, solid aspect, thus making us believe that it is made of some material substance. At the macroscopic level, this notion of substance is a useful approximation, but at the atomic level, it no longer makes sense. Atoms consist of particles, and these particles are not made of any material stuff. When we observe them, we never see any substance. What we observe are dynamic patterns continually changing into one another, a continuous dance of energy." Stanislav Grof wrote, "Prior to Einstein's theory of relativity and quantum physics, we held a firm conviction that the universe was composed of solid matter. We believed that the basic building blocks of this material universe were atoms, which we perceived as compact and indestructible. The atoms existed in three-dimensional space, and their movements followed certain fixed laws. Accordingly, matter evolved in an orderly way, moving from the past through the present into the future. Within this image of the universe developed by Newtonian science, life, consciousness, human beings, and creative intelligence were seen as accidental byproducts that evolved from a dazzling array of matter. As complex and fascinating as we might be, we humans were nevertheless seen as being essentially material objects, little more than highly developed animals or biological thinking machines. Our boundaries were defined by the surface of our skin, and consciousness was seen as nothing more than the product of that thinking organ known as the brain. On a metaphysical level, the Newtonian worldview has instilled a common belief that all life, consciousness, and the diversity of nature are merely serendipitous accidents evolving out of complex interactions between particles of physical matter. The idea that life, consciousness, and the complexity of nature arose by accident, for holistic thinkers, seems like a ludicrous improbability, but for so-called logical, scientific thinkers, this worldview has long-standing merit. Many are happy to accept that space, time, and matter all spontaneously came from nowhere, for no reason, that a sneezing singularity expanded and evolved through trial and error and survival of the fittest over billions of years. At some point, somehow, life and consciousness arose from non-living, unconscious matter, then continued gaining complexity through time until humanity, the pinnacle of billions of years of mechanical evolution, emerged. With all these perceptions, sensations, emotions, and internal experiences, just by accident. Stanislav Graf wrote, "Traditional science holds the belief that organic matter and life grew from the chemical ooze of the primeval ocean solely through the random interactions of atoms and molecules. Similarly, it is argued that matter was organized into living cells, and cells into complex multicellular organisms with central nervous systems solely by accident and natural selection. And somehow, along with these explanations, the assumption that consciousness is a byproduct of material processes occurring in the brain has become one of the most important metaphysical tenets of the Western worldview. As modern science discovered the profound interactions between creative intelligence and all levels of reality, this simplistic image of the universe becomes increasingly untenable. The probability that human consciousness and our infinitely complex universe could have come into existence through the random interactions of inert matter has aptly been compared to that of a tornado blowing through a junkyard and accidentally assembling a 747 jumbo jet." Dean Radin wrote, "Many processes certainly appear to be explainable in approximately mechanistic reductionistic terms. But as physicists have delved progressively deeper into the nature of reality, they find that it cannot be understood in mechanistic terms. Mechanism assumes that there are separate objects that interact in determined causal ways, but that's not the reality we live in. Quantum reality is holistic, and as such, any attempt to study its individual pieces will give an incomplete picture. It's like studying atoms inside an acorn in an attempt to understand the emergence of leaves on an oak tree, a futile exercise." One of the most important and mind-bending findings in quantum physics, which has helped us to better understand the nature of matter, was first demonstrated in what is known as the double-slit experiment. This experiment involves projecting photons, electrons, or other quanta through a barrier with two small holes and measuring the way they are detected before, during, and after their travels. Common sense suggests that if they begin as particles, they will travel as particles and end up as particles, but the evidence shows something quite different. Greg Braden wrote, "Scientists have found that when an electron, for example, passes through the barrier with only one opening available, it behaves in just the way we'd expect it to. It begins and ends its journey as a particle. In doing so, there are no surprises. In contrast, when two slits are used, the same electron does something that sounds impossible. Although it definitely begins its journey as a particle, a mysterious event happens along the way. The electron passes through both slits at the same time, as only a wave of energy can do, forming the kind of pattern on the target that only an energy wave can make." Dean Radin wrote, "In the classical double-slit experiment, a stream of photons, or electrons, or any atomic-sized object, are shot at a screen with two tiny slits in it. On the other side of the screen, a photographic plate or sensitive video camera records where each photon lands. If one of the slits is closed, then the camera will see a smooth distribution of photons with the peak intensity directly opposite the open slit. This is what common sense would predict if the photons were individual particles. But if you open both slits, the camera sees a different pattern, an interference pattern with varying bands of high and low intensity, that is consistent with the photons being a wave. Furthermore, when physicists lower the light intensity to shoot only one photon at a time, somehow they get the same results. With one slit open, each photon shoots through and lands on the screen evenly distributed, peak intensity perfectly aligned. So with two slits open, firing one photon at a time, you might likewise assume to see two even distributions perfectly aligned behind each slit. However, just like when firing a flood of photons through, somehow the photons know the second slit is open, pass through both slits simultaneously, and end up on the screen as a wave-like interference pattern. This experiment and many similar replications have produced the same results every single time. The quanta begin as single particles, shoot through the apparatus, register going through both slits simultaneously, and then show up interfered with themselves on a screen. Each individual particle is somehow interfering or entangling with itself as a wave. This phenomenon has come to be known as particle-wave duality." Michael Talbot wrote, "The electron, like some shapeshifter out of folklore, can manifest as either a particle or a wave. This chameleon-like ability is common to all subatomic particles. It is also common to all things once thought to manifest exclusively as waves. Light, gamma rays, radio waves, X-rays, all can change from waves to particles and back again. Today, physicists believe that subatomic phenomena should not be classified solely as either waves or particles, but as a single category of somethings that are always somehow both. These somethings are called quanta, and physicists believe that they are the basic stuff from which the entire universe is made. This particle-wave duality is a significant discovery because it shows that the basic building blocks of our physical reality, not only are they 99% empty space, but they constantly fluctuate between being precise, definable particles and unlimited probability waves. Thus, the philosophical questions arise: what determines whether they are particles or waves? How can something be in two states at one time? How can the building blocks of matter be so immaterial? Peter Russell wrote, "With the development of quantum theory, physicists have found that even subatomic particles are far from solid. In fact, they are not much like matter at all. At least nothing like matter as we know it. They can't be pinned down and measured precisely. Much of the time they seem more like waves than particles. They are like fuzzy clouds of potential existence with no definite location. Whatever matter is, it has little, if any, substance." Lynn McTaggart wrote, "Matter, at its most fundamental level, cannot be divided into independently existing units, or even be fully described. Subatomic particles aren't solid little objects like billiard balls, but vibrating and indeterminate packets of energy that cannot be precisely quantified or understood in themselves. Instead, they are schizophrenic, sometimes behaving as particles, a set thing confined to a small space, and sometimes like a wave, a vibrating and more diffuse thing spread out over a large region of space and time, and sometimes like both a wave and a particle at the same time." Using the example of water, we see an illustration of how something can be both a particle and wave simultaneously. If you separate a drop of water from the ocean, then it is an independent, distinct particle with definite location. However, put that same drop of water back into the ocean, and it becomes part of an integral, undifferentiated wave with no definite location. From the perspective of the individual H2O molecules, nothing changes regardless of whether they are a drop or an ocean wave. The wave-particle distinction comes from us, the conscious observers, which brings us to another question. In the double slit experiment, how does the particle know whether or not the second slit is open? Why does it act like a particle when one slit is open, but act like a wave when two slits are open? Greg Braden wrote, "The only explanation here is that the second opening has somehow forced the electron to travel as if it were a wave. To do so, the electron has to somehow perceive that the second opening exists and has become available. And this is where the role of consciousness comes in. Because it's assumed that the electron cannot really know anything in the truest sense of the word, the only other source of awareness is the person watching the experiment. The conclusion here is that somehow the knowledge that the electron has two possible paths to move through is in the mind of the observer, and that the onlooker's consciousness is what determines how the electron travels. It seems the particles themselves are somehow conscious of the slits, or the scientist's consciousness is informing the particles. Either way, two amazing things are happening here, which rock the foundations of classical physics. Firstly, photons, electrons, and all quanta are simultaneously expressing the properties of both particles and waves. Secondly, the quanta are essentially conscious and/or reading our minds. Dean Radin wrote, "This rather simple experiment raises a central question about the role of the observer in quantum reality. This is known as the quantum measurement problem. We infer that the photon acts like a wave when we're not looking, but we never actually see those waves. So what causes the photon to collapse into a particle when we do decide to look at it? In classical physics, objects are regarded as objectively real and independent of the observer. In the quantum world, this is no longer the case." Lynn McTaggart wrote, "The quantum pioneers discovered that our involvement with matter was crucial. Subatomic particles exist in all possible states until disturbed by us, by observing or measuring, at which point they settle down, at long last, into something real. Our observation, our human consciousness, is utterly central to this process of subatomic flux actually becoming some set thing. The peculiar discovery known as the quantum measurement problem ultimately shows the inseparability of the observer from the observed. All quantum experiments have confirmed that there is no measurable solid reality out there independent of the measurer. What is out there, when we're not looking, is an infinite wavy cloud of crisscrossing possibilities. Then, when we focus our attention on something, the wave function collapses into a defined particle in a definite location for us to observe." Jim Al-Khalili wrote, "If you want to see fear in a quantum physicist's eyes, just mention the words, 'the measurement problem.' The measurement problem is this: an atom only appears in a particular place if you measure it. In other words, an atom is spread out all over the place until a conscious observer decides to look at it. So the act of measurement, or observation, creates the entire universe." Lynn McTaggart wrote, "An electron is not a precise entity, but exists as a potential, a superposition or sum of all probabilities until we observe or measure it, at which point the electron freezes into a particular state. Once we are through looking or measuring, the electron dissolves back into the ether of all possibilities." Physicist Fred Alan Wolf uses the term popping the quiff, QWF for quantum wave function, to describe the role of the observer in creating reality. Before being consciously observed, quanta, the building blocks of all matter, exist only as a boundaryless wave of undifferentiated quantum energy. In this state, there is no matter as such, no particles or things with attributes and definite locations, just an infinite expanse of energy, 0 point, the field. However, when a conscious observer focuses attention, they pop the quiff, collapse the quantum wave function into a solid particle of experience with definable attributes and location. Lynn McTaggart wrote, "One of the fundamental laws of quantum physics says that an event in the subatomic world exists in all possible states until the act of observing or measuring it freezes it or pins it down to a single state. This process is technically known as the collapse of the wave function, where wave function means the state of all possibilities. Although nothing exists in a single state independently of an observer, you can describe what the observer sees, but not the observer himself. You include the moment of observation in the mathematics, but not the consciousness doing the observing. There is no equation for an observer. According to the mathematics, the quantum world is a perfect hermetic world of pure potential, only made real when interrupted by an intruder." These findings are so significant because they prove that the classical Newtonian model of physics, now being termed the old physics, is fundamentally flawed. The old physics described a mechanistic, material universe out there, existing regardless of whether or not there was a conscious being alive to perceive it. The new physics shows that matter doesn't even exist without consciousness. Without a conscious observer to pop the quiff, there is no substance, no materiality to that which is just an unlimited, undifferentiated field of energy. As stated in the excellent quantum physics documentary, What the Bleep Do We Know? When you are not looking, there are waves of possibility. When you are looking, there are particles of experience. Anton Zellinger wrote, "What is real depends on whether I look, and the way I look. This is not just a philosophical question. We can see this in experiments." Lynn McTaggart wrote, "Cause and effect relationships no longer hold at the subatomic level. Stable-looking atoms might suddenly, without apparent cause, experience some internal disruption. Electrons, for no reason, elect to transit from one energy state to another. Once you peer closer and closer at matter, it isn't even matter, not a single solid thing you can touch or describe, but a host of tentative selves, all being paraded around at the same time. Rather than a universe of static certainty, at the most fundamental level of matter, The world and its relationships are uncertain and unpredictable, a state of pure potential, of infinite possibility. Another interesting anomaly of the quantum world is known as the uncertainty principle. Discovered by German physicist Werner Heisenberg, Heisenberg's uncertainty principle states that a particle's position and its momentum can never be precisely measured simultaneously. We can obtain precise information about a particle's position as long as we ignore its momentum, or we can obtain precise information about its momentum as long as we ignore its exact position. But in no way can we obtain precise knowledge about both quantities, and this limitation has nothing to do with our measuring techniques. It is a fundamental limitation inherent in atomic reality. Fritjof Capra wrote, "The crucial feature of atomic physics is that the human observer is not only necessary to observe the properties of an object, but is necessary even to define these properties. In atomic physics, we cannot talk about the properties of an object as such. They are only meaningful in the context of the object's interaction with the observer. In the words of Heisenberg, what we observe is not nature itself, but nature exposed to our method of questioning. The observer decides how he is going to set up the experiment, and this arrangement will determine to some extent the properties of the observed object. If the experimental arrangement is modified, the properties of the observed object will change in turn." Again, the uncertainty principle, as in the double-slit studies, shows the importance of the observer in determining the outcome of quantum experiments. Another such example of this is often termed the watched quantum pot experiment. Just as the old proverb states, "A watched pot never boils." Likewise, in the quantum world, this strangely proves true, as verified by physicists Wayne Itano, Yakir Aharonov, and M. Vardy. They state that if one checks by continuous observations if a given quantum system evolves from some initial state to some other final state along a specific trajectory, the result is always positive, whether or not the system would have done so on its own accord. Fred Alan Wolf wrote, "If a quantum system is monitored continuously, we could say vigilantly, it will do practically anything. For example, suppose you are watching a quantum system in an attempt to determine just when it undergoes a transition from one state to another. To make this concrete, think of an imaginary subatomic quantum pot of water being heated on a similarly sized stove. The transition occurs when the water goes from the calm state to the boiling state. We all know pots of water boil, given a few minutes or so. You would certainly think the watched quantum pot would also boil. It turns out, because of the vigilant observations, the transition never occurs. The watched quantum pot never boils." Another example is the decay of an unstable system. On its own, the system would decay in a few microseconds, but if it is watched continuously, it will never decay. All vigilantly watched quantum pots never boil, even if they are heated forever. So a watched quantum pot, or particle, will boil, transition states, if you intently observe it to do so, and a watched quantum pot will never boil if you intently observe it not to do so. Even the radioactive decay of subatomic particles, which normally have the lifespan of microseconds, can be prolonged indefinitely, as long as we are watching. Fred Alan Wolf wrote, "This implies that there is a deep connection between the observer and the observed. So deep, in fact, that we really cannot separate them. All we can do is alter the way we experience reality. This is where intent comes in. If the system were unobserved, it would certainly undergo the physical transition. The pot would boil. The observer effect causes the anomaly to occur. Let me explain. When the system is first observed, it is seen to be in its initial state. When it is observed just a smidgen of time later, well before the time in which it should change, the system is observed with more than 99.99% chance to be in its initial state. In other words, the system is found to be exactly where it was initially. Now repeat this measurement again and again, each time just a tiny bit of time later, and with a very high probability, the same observation occurs. The system is found in its initial state. But time marches on. and eventually we pass all reasonable time limits for the transition to occur, yet it still doesn't happen. The system freezes in its initial state. The only requirement to freeze the motion is that the observer must have the intent to see the object in its initial state when he looks. This intent is determined by the frequency of his observations. We, the observers, cannot be ignored. Our consciousness and our bodies are integral parts of the universe, and thus exhibit measurable effects on whatever aspects of the universe we turn our attention to. Scientists try to observe the world objectively, but they, subjectively performing the experiment, are already an integral part of any objective measurement being taken. Specifically, it is their consciousness, their attention and intention which affect the results. Greg Braden wrote, "It's important to remember that the equations of quantum physics don't describe the actual existence of particles. In other words, the laws can't tell us where the particles are and how they act once they get there. They describe only the potential for the particles' existence, that is, where they may be, how they might behave, and what their properties could be like. And all of these characteristics evolve and change over time. These things are significant because we're made of the same particles that the rules are describing. If we can gain insight into the way they function, then maybe we can become aware of greater possibilities for how we work. Herein lies the key to understanding what quantum physics is really saying to us about our power in the universe. Our world, our lives, and our bodies exist as they do because they were chosen, imagined, from the world of quantum possibilities. Which of the many possibilities becomes real appears to be determined by consciousness and the act of observation. In other words, the object of our attention becomes the reality of our world." Amit Goswami wrote, "Quantum physics calculates only possibilities, but if we accept this, then the question immediately comes, who or what chooses among these possibilities to bring the actual event of experience? So we directly, immediately, see that consciousness must be involved. If the underlying unity of energy in the universe exists as an infinite anything of possibilities, and it is consciousness which chooses and experiences all manifestations of the infinite anything, then it would seem that consciousness is much more fundamental and primary than classical physics espouses. If consciousness is what changes waves of possibility into particles of experience, then how could consciousness be some emergent property of the material universe? The material universe doesn't even exist yet without immaterial consciousness existing to have that experience." Bernard d'Espagnat wrote, "The doctrine that the world is made up of objects whose existence is independent of human consciousness turns out to be in conflict with quantum mechanics and with facts established by experiment." Ervin Laszlo wrote, "Leading physicist Lee Smolin has estimated that from its inception, had the primary forces and physical attributes of our universe varied by more than an unimaginably precise 1 part in 10 to the 27th power, that's 1 part in 1,000 trillion trillion, our complex universe of chemistry, galaxies, and biological life could not have evolved. The odds of our universe containing these precise forces and physical attributes are 1 in 1 octillion, without which matter and life could not have emerged. If that's not a strong case for intelligent design, I don't know what is. The old physics claims that life, consciousness, the incredible beauty and diversity of nature, is all the result of chance, even though the odds against chance are 1,000 trillion trillion to 1. Personally, for me, the idea that our universe exists due to non-intelligent, random, mechanical forces is utterly laughable. Just by sitting in meditation, smelling a flower, watching an eclipse, hearing children's laughter, tasting ice cream, or feeling an orgasm, it is quite clear to me that the universe was intelligently and purposefully designed." In his 2005 Nature magazine article, The Mental Universe, Johns Hopkins physics professor Dr. R.C. Henry bluntly recommends we get over it and accept the logical conclusion that the universe is immaterial, mental, and spiritual. In the same article, Cambridge physicist Sir James Jeans is quoted as saying, "The stream of knowledge is heading toward a non-mechanical reality." the universe begins to look more like a great thought than like a great machine. Mind no longer appears to be an accidental intruder into the realm of matter. We ought rather hail it as the creator and governor of the realm of matter. Dr. Jeffrey Satinover wrote, "Matter is not what we have long thought it to be. To the scientist, matter has always been thought of as sort of the ultimate in that which is static and predictable. We like to think of space as empty and matter as solid, but in fact, there is essentially nothing to matter whatsoever. It's completely insubstantial. The most solid thing you can say about all this insubstantial matter is that it's more like a thought. It's like a concentrated bit of information." British astrophysicist Sir Arthur Eddington said that physics is the study of the structure of consciousness. The stuff of the world is mind stuff. Even Nobel Prize-winning physicist Max Planck, the father of quantum physics, before his passing in 1947, conceded that, as a man who has devoted his whole life to the most clear-headed science, to the study of matter, I can tell you, as the result of my research about the atoms, this much. There is no matter as such. All matter originates and exists only by virtue of a force which brings the particles of an atom to vibration and holds this most minute solar system of the atom together. We must assume behind this force the existence of a conscious and intelligent mind. The mind is the matrix of all matter. Greg Braden wrote, "With these words, Max Planck, the father of quantum theory, described a universal field of energy that connects everything in creation, the divine matrix. The divine matrix is our world. It is also everything in our world. It is us and all that we love, hate, create, and experience. Living in the divine matrix, we are as artists expressing our innermost passions, fears, dreams, and desires through the essence of a mysterious canvas. We are the paints as well as the brushes. In the divine matrix, we are the container within which all things exist, the bridge between the creations of our inner and outer worlds, and the mirror that shows us what we have created." Another two mind-bending, paradigm-shattering findings in the new physics are known as non-locality and quantum entanglement. In classical physics, objects were seen as localized and isolated from one another within space. Through dozens of replicated and verified experiments, we now know, however, that the universe at the quantum level is entangled, non-local, one integrated whole. Lynn McTaggart wrote, "Quantum physicists discovered a strange property in the subatomic world called non-locality. This refers to the ability of a quantum entity, such as an individual electron, to influence another quantum particle instantaneously over any distance, despite there being no exchange of force or energy. It suggests that quantum particles, once in contact, retain a connection even when separated, so that the actions of one will always influence the other, no matter how far they get separated. Before the advent of quantum physics, Albert Einstein, still thinking in the classical paradigm, thought that nothing in the universe could travel faster than light. In the past 2 decades, however, it has been experimentally proven that one thing can indeed move faster than the speed of light: information. Information can be sent between two objects at any distance, instantaneously." Greg Braden wrote, "In 1997, scientific journals throughout the world published the results of something that traditional physicists say shouldn't have happened. Reported to over 3,400 journalists, educators, scientists, and engineers in more than 40 countries, an experiment had been performed by the University of Geneva in Switzerland on the stuff that our world is made of, particles of light called photons, with results that continue to shake the foundation of conventional wisdom. This groundbreaking experiment conclusively proved the existence of quantum entanglement, which is basically a fancy name for instantaneous information travel. First, scientists took single photons and split them into separate twin particles with identical properties. Then they fired both particles away from each other in opposite directions through specially designed fiber optic chambers. At the end of these long pathways, the twin particles were forced to choose between two random but exactly identical routes. Curiously, without fail, in every trial, The particles made precisely the same choices and traveled the same paths. Classical physics has always assumed that separate particles have no communication with one another, but quantum physics has now proven that assumption erroneous. The first entanglement experiments were designed and tested in 1982 by French physicist Alain Aspect at Orsay's Institut d'Optique. These crude but conclusive studies later inspired Nicolas Gislin's University of Geneva group of physicists to replicate them at greater distances. In 1997, Gislin built a 14-mile fiber optic chamber and repeated Aspect's experiments with exactly the same results. Later, in 2004, Gislin extended the chamber to 25 miles, and once again, as usual, no matter how far apart, the particles always chose and traveled the same random pathways. Jake Horsley wrote, "Quantum mechanics has shown through experimentation that particles, being after all but moving points on some infinite wave, are in communication with one another at all times. That is to say, if our quantum mechanic does something to particle A over in Cincinnati, Ohio, planet Earth, the experience of this event will be instantly communicated to particle Z at speeds faster than light over in Zeta Reticuli. What this suggests is that anything one given particle experiences can be experienced by another particle simultaneously, and perhaps even by all particles everywhere. The reason for this is that they are all part of the same wave, the same energy flow." Greg Braden wrote, "For a message to travel between them, it would have to be moving faster than the speed of light, but according to Einstein's theory of relativity, nothing can travel that quickly. So is it possible that these particles are violating the laws of physics? Or are they demonstrating something else to us? Could they be showing us something so foreign to the way we think about our world that we're still trying to force the mystery of what we see into the comfortable familiarity of how we believe energy gets from one place to another? What if the signal from one photon never traveled to reach the other? Is it possible that we live in a universe where the information between photons, the prayer for our loved ones, or the desire for peace in a place halfway around the world, never needs to be transported anywhere to be received? The answer is yes. This appears to be precisely the kind of universe we live in. Robert Nadeau, historian of science, and Menes Kafatos, a physicist from George Mason University, wrote an entire book together on the results and implications of quantum entanglement and non-locality, entitled The Non-Local Universe. In it, they state, "All particles in the history of the cosmos have interacted with other particles in the manner revealed by the Aspect experiments. Also consider that quantum entanglement grows exponentially with the number of particles involved in the original quantum state, and that there is no theoretical limit on the number of these entangled particles. If this is the case, the universe on a very basic level could be a vast web of particles which remain in contact with one another over any distance in no time, in the absence of the transfer of energy or information. This suggests, however strange or bizarre it might seem, that all of physical reality is a single quantum system that responds together to further interactions." Nadeau and Kafatos argue that we live in a non-local universe, which is the obvious conclusion from the quantum entanglement experiments. The fact is, quanta can exchange information over any distance in the universe instantaneously. These entanglement experiments prove that Einstein was incorrect in stating that nothing travels faster than light, 186,000 miles per second. Quantum information travels at infinite speed, arriving at its destination without any time elapsing. Here we see how the Newtonian-Einsteinian language of local universe fails to describe our actual reality. It's not that information is traveling at infinite speed to arrive at another location, but rather that the universe with all its so-called parts and particles is actually one non-local quantum system. Information from one particle to another doesn't need to travel there, because the space between them is illusory, as is the language of calling them separate particles. As we have seen, before observation, quanta are not particles with definite attributes and location. They are merely waves in the one universal quantum ocean, until our conscious observation individualizes the wave into droplets of experience. Lynn McTaggart wrote, "Non-locality shatters the very foundations of physics. Matter can no longer be considered separate. Actions do not have to have an observable cause over an observable space. Einstein's most fundamental axiom isn't correct. At a certain level of matter, things can travel faster than the speed of light. Subatomic particles have no meaning in isolation, but can only be understood in their relationships. The world, at its most basic, exists as a complex web of interdependent relationships, forever indivisible." Dean Radin wrote, "As an aside, it's interesting to note that Nadeau and Kafetos mention early in their book that readers accidentally encountering their book in the New Age section of a bookstore would likely be disappointed. That's because the book is about physics and not New Age ideas. But the fact that Nadeau and Kafetos felt it important to mention this at all illustrates the rising tension between the leading edge of interpretations in physics and the tail end of metaphysics. Physicists interested in quantum ontology are painfully aware that some interpretations of quantum reality are uncomfortably close to mystical concepts. In the eyes of mainstream science, to express sympathy for mysticism destroys one's credibility as a scientist. Thus, the taboo persists. The old view was a material universe, separated by objective space and time, a clockwork machine operating under fixed laws which evolved in complexity until consciousness, the ability to experience, mysteriously manifested into the first ever self-aware unit of now living matter. No scientist, however, could explain how something as complex as life and consciousness, our complex immaterial internal worlds of thought, emotion, sensation, and perception, could ever arise from something as simple as random interactions of physical matter. No biological, chemical, electrical, magnetic, or other quantitative, qualitative such formula can ever explain how consciousness could emerge from mere physical interactions of non-experiencing, non-living, unconscious particles of matter." Amit Goswami wrote, "In the old thinking, I cannot change anything because I don't have any role at all in reality. Reality is already there. It is material objects moving in their own way, from deterministic laws and mathematics. I, the experiencer, have no role at all. In the new view, yes, mathematics can give us something. It gives us the possibilities that all these movements can assume, but it cannot give us the actual experience that I'll be having in my consciousness. I choose that experience, and therefore, literally, I create my own reality. It may sound like a tremendous, bombastic claim by some new agey without any understanding of physics whatsoever, but really, quantum physics is telling us that." Fritjof Capra wrote, "Quantum theory has thus demolished the classical concepts of solid objects and of strictly deterministic laws of nature. At the subatomic level, the solid material objects of classical physics dissolve into wave-like patterns of probabilities, and these patterns ultimately do not represent probabilities of things, but rather probabilities of interconnections. A careful analysis of the process of observation in atomic physics has shown that the subatomic particles have no meaning as isolated entities, but can only be understood as interconnections between the preparation of an experiment and the subsequent measurement. Quantum theory thus reveals a basic oneness of the universe. It shows that we cannot decompose the world into independently existing smallest units. As we penetrate into matter, nature does not show us any isolated basic building blocks, but rather appears as a complicated web of relations between the various parts of the whole. These relations always include the observer in an essential way. The human observer constitutes the final link in the chain of observational processes, and the properties of any atomic object can only be understood in terms of the object's interaction with the observer." Princeton physicist and colleague of Albert Einstein, Dr. John Wheeler, often remarked that nothing is more important in quantum physics than the observer effect and the measurement problem, because they destroy the materialist concept of the world sitting out there, with the observer safely separated from it by a 20-centimeter slab of plate glass. Even to observe something as minuscule as an electron, that slab of plate glass must be shattered. The scientist must reach in, install his devices, and decide whether to measure position or momentum. It is up to him which he decides, but installing the equipment to measure one prevents and excludes the possibility of measuring the other, because his act of measuring actually changes the state of the electron. Due to the free-willed decision of the observer, the universe afterwards will never again be the same. Thus, to accurately describe what has happened, Wheeler insisted that the old word observer must be replaced with the new word participator, because in some strange and fantastic way, our universe is a participatory universe. Greg Braden wrote, "What a shift! In a radically different interpretation of our relationship to the world we live in, Wheeler states that it's impossible for us to simply watch the universe happen around us. Experiments in quantum physics, in fact, do show that simply looking at something as tiny as an electron, just focusing our awareness upon what it's doing for even an instant in time, changes its properties while we're watching it. The experiments suggest that the very act of observation is an act of creation, and that consciousness is doing the creating. These findings seem to support Wheeler's proposition that we can no longer consider ourselves merely onlookers who have no effect on the world we're observing." Fritjof Capra wrote, "The idea of participation instead of observation has been formulated in modern physics only recently, but it is an idea which is well known to any student of mysticism. Mystical knowledge can never be obtained just by observation, but only by full participation with one's whole being. The notion of the participator is thus crucial to the Eastern worldview, and the Eastern mystics have pushed this notion to the extreme, to a point where observer and observed, subject and object, are not only inseparable, but also become indistinguishable, where the observer and the observed cannot be separated, but can still be distinguished. They go much further, and in deep meditation they arrive at a point where the distinction between observer and observed breaks down completely, where subject and object fuse together into a unified, undifferentiated whole. Mystics, yogis, shamans, Eastern philosophers, and the like have no trouble whatsoever understanding quantum physics. These amazing discoveries causing such a stir among the scientific community are really just experimental proofs of ancient wisdom long understood by such simple folk. The ideas of cosmic mind and the participatory universe are already fundamental tenets of their worldview. It is only modern Westerners raised on the materialist paradigm that find these facts puzzling." Fermi Award-winning American physicist, successor to Albert Einstein at Princeton's IAS, and director of the Manhattan Project, Dr. Robert Oppenheimer, was well aware of quantum physics' uncanny resemblance to Eastern philosophy. He once stated that the general notions about human understanding, which are illustrated by discoveries in atomic physics, are not in the nature of things wholly unfamiliar, wholly unheard of, or new. Even in our own culture, they have a history, and in Buddhist and Hindu thought, a more considerable and central place. What we shall find is an exemplification, an encouragement, and a refinement of old wisdom. Nobel Prize-winning German physicist, successor to Max Planck, and pioneer of the uncertainty principle, Dr. Werner Heisenberg, was also well aware of the parallels between quantum physics and Eastern thought. He stated that the great scientific contribution in theoretical physics that has come from Japan since the last war may be an indication of a certain relationship between philosophical ideas in the tradition of the Far East and the philosophical substance of quantum theory. Lynn McTaggart wrote, "We are poised on the brink of a revolution as daring and profound as Einstein's discovery of relativity. At the very frontier of science, new ideas are emerging that challenge everything we believe. Discoveries are being made that prove what religion has always espoused, that human beings are far more extraordinary than an assemblage of flesh and bones. Human beings and all living things are a coalescence of energy in a field of energy connected to every other thing in the world. This pulsating energy field is the central engine of our being and our consciousness. There is no me and not me duality to our bodies in relation to the universe, but one underlying energy field." Adrian Cooper wrote, "Quantum physics illustrates how everything in the universe, in all dimensions of life and reality, ultimately consists of quanta, of energy, vibration. This energy not only pervades and is integral to everything in existence, it is also living mind, living consciousness. Everything in the universe therefore has its being within this infinite intelligent energy. Everything is an aspect of this infinite intelligence. Every person, every animal, every tree, every star and every planet, and every microorganism, however small, is ultimately an equal aspect of the very same energy. There is no separateness, except as an illusion, created by the ego and 5 physical senses. We and everything in the universe, without exception, are one. In Hinduism, Mahamaya is the goddess personifying the power to create the material universe. In Buddhism, Buddha's supernatural mother is known as Maya. In ancient Egypt, Ma'at or Mayat was the female goddess responsible for setting order and balance at the moment of creation. The Indian word Maya has the same meaning as the Mesoamerican Mayan civilization half a world away. In both cultures, Maya loosely translates to illusion or delusion, as both peoples believed the entire physical universe to be an illusion, a delusion of our consciousness, separating our fundamental oneness, the Father, into individualized subjective perspectives throughout time and space, the Mother, matter, mat, Mayan illusion. Fred Allen Wolfe wrote, "So it is conceivable that all of this really is just a great illusion, that we have no way of really getting outside of to see what is really out there. Your brain doesn't know the difference between what's taking place out there and what's taking place in here. There is no out there, independent of what's going on in here." Adrian Cooper wrote, "One of the discoveries that proved to be most astonishing to physicists was the observation that the only time quanta ever manifest as particles is when people are actually looking at them. The significance of this realization alone is extremely profound in terms of the understanding of the material world and all of creation. The wisdom of the ages has always maintained and taught the physical world of matter is nothing but an illusion, only perceived by most as reality, due to observation and experience by the mediation of the 5 physical senses. Everything, the entire material universe, at the most fundamental level, is simply one undifferentiated, interconnected energy resonating at various frequencies. Solid matter, for instance, is energy of a very slow, dense vibration, such as H2O in ice form. In a block of ice, the collective vibration of H2O molecules slows and freezes into a rigid, highly structured alignment. The vibration of that block of ice is so slow that your hand cannot pass through the dense mass of H2O molecules. However, if you take that same mass of molecules and raise the temperature so they vibrate at a faster rate, then the rigid, impenetrable solidity gives way to more flowing, fluid, chaotic, lower density liquid state, water, which your hand can pass right through. If you continue heating the same mass of molecules, causing them to vibrate even faster, then that flowing liquid state gives way to an even more chaotic, lower density, free-form, gaseous state, steam, which your hand passes through with even less resistance than water. This example illustrates how materiality is simply an illusion created by interfering energy patterns of various vibrations decoded by mind or consciousness. Adrian Cooper wrote, "Quantum physicist David Bohm was absolutely correct when he made the observation that the physical universe is actually frozen light. This can be likened to the process of water freezing. As water gets progressively colder, the molecules comprising that water progressively slow down as they vibrate at lower rates of energy, of which they ultimately comprise, until eventually the energy vibration of the molecules becomes too low to sustain the water as a liquid, at which point the water freezes and becomes ice. The physical composition of the ice and the atoms and molecules that comprise it are exactly the same as when it existed as water, the only difference being that as ice, the energy that ultimately comprises that water or ice is now vibrating at a much lower level. Exactly the same principle applies to the existence of the physical universe within the greater universe as a whole. As energy vibrates at a progressively lower rate and density increases as a result, there came a point during the initial creation of the universe where the vibrations of energy became too low to be sustainable in its usual fine free energy form, and therefore differentiated into particles of various increasing sizes, ultimately manifesting as matter, the physical universe, as observed by science and people on Earth generally. Classical physics and the old science taught us that human beings were mere survival machines powered by chemicals and genes. They taught us that the brain was the originator of consciousness, and that our internal worlds of thought, emotion, sensation, and morality were mere byproducts of material evolution. They taught us that we humans were separate, isolated entities in a desolate, mechanical, clockwork universe. They taught us that time and space were finite, and that nothing traveled faster than light. Quantum physics and the new science, however, teach us that human beings are spiritual entities having this physical experience. They teach us that consciousness is the primary mind stuff of the universe, and that time, space, and matter exist only within and by virtue of consciousness. They teach us that we humans are indivisible from our environment and each other, that our bodies, the stars, and space are composed of one undifferentiated expanse of vibrating energy. In short, the old material science brought us a disempowering message of division and haphazard coincidence. The new spiritual science brings us the empowering message of absolute unity and divine cosmic mind. Dr. Stanislav Grof wrote, "Western science is approaching a paradigm shift of unprecedented proportions, one that will change our concepts of reality and of human nature, bridge the gap between ancient wisdom and modern science, and reconcile the differences between Eastern spirituality and Western pragmatism." Fritjof Capra wrote, "The exploration of the atomic and subatomic world in the 20th century has revealed an unsuspected limitation of classical ideas, and has necessitated a radical revision of many of our basic concepts. The concept of matter in subatomic physics, for example, is totally different from the traditional idea of a material substance in classical physics. The same is true for concepts like space, time, or cause and effect. These concepts, however, are fundamental to our outlook on the world around us, and with their radical transformation, our whole worldview has begun to change. These changes, brought about by modern physics, have been widely discussed by physicists and philosophers over the past decades, but very seldom has it been realized that they all seem to lead in the same direction, towards a view of the world which is very similar to the views held in Eastern mysticism. And if physics leads us today to a worldview which is essentially mystical, it returns in a way to its beginning, 2,500 years ago. It is interesting to follow the evolution of Western science along its spiral path, starting from the mystical philosophies of the early Greeks, rising and unfolding in an impressive development of intellectual thought that increasingly turned away from its mystical origins to develop a worldview which is in sharp contrast to that of the Far East. In its most recent stages, Western science is finally overcoming this view and coming back to those of the early Greek and early Eastern philosophies. This time, however, it is not only based on intuition, but also on experiments of great precision and sophistication, and on a rigorous and consistent mathematical formalism. David Icke wrote, "Quantum physics, which explores reality beyond the physical world of the atom, is saying basically the same as the mystics and people like me, who talk of different dimensions and frequencies of existence interpenetrating our own. Spirituality and true science, in its open-minded, open-hearted form, are essentially at one. It is mainstream science and mainstream religion that has caused the apparent rift, because they are slaves to arrogance, ignorance, and dogma. One is not science, and the other is not spiritual. They are two polarities of the same falsehood. The open-minded quantum physicist would have no problem with most of what I am going to say in this book, while the cap-touching, protecting my funding mainstream scientist would roll his eyes in bewilderment. Such is the chasm of view that exists in the so-called scientific community."